I said, once we did all that, we get this long equation. But I simply just put all the like terms together, and this is what I got. Okay. So we have cosine. Since we had this is already a common factor, so I just put them all together. So you got the cosine of 120t times 120b plus 100a plus the sine of 120t times negative 120a plus 100b equals the cosine, 100 cosine of 100t plus 0 sine 120t. The 0 sine, it's optional. I just do it just to keepsake. But the 0 sine, that's literally just because there is no sine in our original equation. So I just put 0 sine just to have it there. So we will solve for b and a by comparing coefficients. So you can see on both sides, there's a cosine of 120t. On both sides, cosine 120t. But there's 100 right here, and there's this long little equation right here. So we have cosine 100t and cosine 100t. So this 100 right here is the sum of this 120b plus 100a. So then we can put as an equation 120b plus 100a is equal to 100. The same thing can be said about the sine. We have a sine 120 here, sine 120 there. You already know the drill. This 0 is the sum of these two right here. So we have 120a plus 100b equals 0. And honestly, to solve for this, you can choose either A or B. In this case, I'll just choose B because you're going to basically solve it terms into the other and plug it into the other equation. So for this one, I chose B as the one I want to solve for. So then if we do all that, you just get 120b, is equal to 100 minus 100a. And then you get 120b. Divide both sides by 120, and you literally just get b. Wait, actually, no. Let's use this one since this one has a 0 already. It's easier to work with. So if I solve for b right here, you get, well, actually, you can bring that over here. So actually, 120a plus 0 equals 100b. Divide both sides by 100. And we get b is equal to about 1.2a. My mistake. But yeah, once you get that, you get b is equal to 1.2a. And then you can plug that back into your first equation, which will give you 120 times 1.2a is equal to, plus 100a is equal to 100. Now you simply, after that, you just simply solve for a. You get 144a plus 100a is equal to 100, which you can then put as 244a is equal to 100, and you already know the process. Divide both sides by 244, and you roughly get, let's see if my math is right. Let's see, 100 over 244, it's like 25 over 61. If I'm mistaken, use my calculator to check. Yep, that's right. 25 over 61. So that's our A. And then once you get that, you can just plug that back in and solve for B. Now that B is equal to 1.2a, which means that B is equal to 1.2 times 25 over 61, which is, terms. This is about 6.5 and then 5, 5. So you get 6 times 5 divided by 61, 60. I mean, 6 is 61. Nope, nothing there. So you just get 61, which equals 30 over 61. And that's our B. So for this one, we have A equals 25 over 61, B equals 30 over 61. Okay. All right. Now, so that means for I of P, and finally, we have steady rate for current equals IP is equal to, or of T is equal to 25 over 61 cosine 120 T volts plus 30 over 61 sine 120 T amps. Now we solve this by plugging this back in, and we just basically add it together, and that'll be our total current equation. I'll say it again. Our total is homogeneous, which is the easier part, and it's the particular or the steady rate current, which is literally just as we just solved for. This is our A, this is our B, and this is the whole thing. Now we do know another piece of information. The time is 0, so T is 0, so that's our initial. We can go ahead and plug in 0 and see what we get. All right, you plug in 0 for T, this is what you get. You're asking what happens to everything. So you plug in 0 for here. This is 100 times 0 goes 0. E to the power of 0 or anything to the power of 0 is just 1. So you get your C right here. The fact that this 25 over 61 is by itself is to go on again. If you know your trig, go ahead and have 0 right here. And you already know cosine of 0 equals 1. So you just multiply this by 1. Same here right here. This one is 0 because we already know our trig again. Sine of 0 is 0. You're not going anywhere, not going up or down, you're just right there. So this is just multiplied by 0, so that's by itself. Now that we have this, we also can remember that we were told that at that time, the inductor had a current of 1 amp. So we can actually set this equal to 1. So we can solve for our C. If you do that, you get, let's see, you get C is equal to 1 minus 25 over 61. And see 61 over 61. So 61 over 61 minus 25 over 61 is equal to 36 over 61. So that's our C. Now that we have that, we can actually finally calculate the final inductor current and voltage. All right, this as I of T equal to, see, now do we have a rate of change? 36 over 30, nope, 61 e to negative 100 t plus 25 over 61 cosine of 120 t plus 30 over 61 sine of 120 t amps. All right. So that's how you write for the final, inductor current. And we just plug in 0, and you'll actually end up getting, this will equals this. This will literally go away, and it's literally just the summation of this and this. And you'll get that. Now for the next part, we have the inductor voltage. We know that term voltage of the inductor equals L di dt, where this right here are given. Again, we're given that L is equal to 0.05. Okay. And then, multiply it by our current, which is d dt. But first, we have to find the derivative of that. So now we're going to find the derivative of this whole thing and multiply that by that. First derivative, you get negative 100 times that. You're basically pulling out the coefficient of the actual t. 120. And you multiply that together, you get negative 3,600 over 61 e to negative 100t minus 3,000 over 61 sine 120t plus 3,600 over 61 cosine 120t. Now that we have our di dt, we're going to multiply both sides by 0.05. And just for head canon and save our heads and not to hurt our heads too much, I'm going to rewrite 0.05 as 1 over 20. That's the equivalent fraction form. Times our little equation, 3,600 over 61 to negative 100t minus 3,000 over 61 sine 120t plus 3,600 over 61 cosine 120t. And then when you multiply together, simplify, you get 180 over 61 e to the negative 100t, minus 150 over 61 120t plus 180 over 61 cosine 120t volts. Now you can find the subsequent voltage by just plugging in 0 and see what you get. It's a very lengthy process, but in order to find the subsequent voltage, current, induction, use this formula in this model, and you'll be able to find it. Thank you.